So are you ready to go start?
Are we ready with this?
Okay.
There you go. Okay, let's go back one.
Yeah.
We good?
It's your account or his account?
It's his account.
Okay, then
Yeah,
Are we all set?
I think so.
Okay.
We good?
Let's check the sound first.
He did.
It is.
Daniel did. He said it was good.
The next speaker is Scott Chapman. He was going to speak about the importance of being prime and tribute to the work of Nick Baeth.
Thank you, Alan, and thank you to the organizers. I can't recall ever having a meeting like this large. This has been wonderful. And when Alfred contacted me about maybe speaking, my first thought was that I would talk about a paper that I wrote with Nick, which is about to appear in the American Math Monthly. And when I thought more about it, there's really nothing in that paper that will surprise anyone in this room. It's an expository paper. So I thought, let's expand this into a tribute to Nick. You know, a lot of us in this room knew him well. For those of you that didn't, Nick passed away early in December of 2021 after a brief battle with pancreatic cancer, which took his life so quickly. It left those of us that worked with him just devastated. And so I thought this would be a really good forum for me to talk about Nick. Now, Roger Wiegand, Sylvia Wiegand, Jim Kuykendall, and I, in March of 2022, went to Nick's home institution for a memorial service for Nick. And it was this really moving tribute to Nick's life. And what I thought I would try to do today, which really couldn't be done at that gathering, is have a celebration of Nick's mathematics and his mathematical career, of which the title is part of the title of the last paper that I wrote with Nick that I'll go into some detail about. So here we go. So here's a familiar face to a whole lot of us. Here's Nick. He was born in Libby, Montana in 1978. He received an undergraduate degree at Pacific Lutheran University and did his graduate work at the University of Nebraska at Lincoln with his thesis under the direction of Roger Wiegand, loosely in module theory, representation theory. So let's take a look at Nick's career for just a second, because I really want to emphasize something for those of us that know Nick. We know this well. But Nick finished his work with Roger and became an assistant professor at Central Missouri University. And look, he spent 13 years there. He rose from an assistant professor, was tenured and promoted to associate, and then in 2015 was promoted to full professor. Now, just prior to that, he did something that he and I share a lot in common. I was a Fulbright visitor here well before 2013, but Nick spent, I believe, a semester here in 2013 under support from the Fulbright Foundation. And I can't emphasize enough how this changed his mathematical life. I'll show you when we kind of review his publications here in a minute. But this visit here had such a deep effect on his mathematics that I think it's fitting that I give this talk here in Graz, because Graz meant a lot to him as it does to many of us. And now, Nick, and I can't emphasize this enough, and this is something I loved about him. He was so driven by his love to teach mathematics and to inspire students to love the mathematics that he loved and to think about it harder and to challenge themselves with really hard problems. There's a lot of debate in the United States. I don't know what it's like here in Europe or in other parts of the world about the relationship between research and teaching. And in my country, there's a lot of people that think they're divorced. I don't, and Nick didn't. To really be a great classroom teacher, you've got to challenge yourself every day with your mathematics. You're going to lose the connection that a student needs to advance if you're not advancing yourself. I know Nick really believed that, and I believe that. We used to talk about that because I spent a lot of time at I'm actually at an institution right now, much like Central Missouri State, but Nick was not satisfied with what was going on at Central Missouri. He didn't think that the emphasis he wanted to give to his professional development, which he felt was necessary to advance his students, he wasn't happy with that. So he left Central Missouri in 2018, and he did the most courageous thing I've seen a mathematician do. He gave up a fully tenured full professorship at Central Missouri and took an assistant professorship without tenure at Franklin and Marshall University, which is in Lancaster, Pennsylvania, because he believed that this institution was going to appreciate the value that he placed on the relationship between research and teaching that he shared, that he had. And I think he was completely right. And he picked his wife and his young son up, went from Missouri to Pennsylvania with no guarantee that the job would work out in the long run. Now, if he had lived, it would have, and we'll talk more about that over the next few minutes. But I can't admire Nick enough for taking this step in his career that I don't think a lot of people would have taken. It really says a lot about Nick. Now, I'm sorry, I need to go back. When I originally thought about this talk, I thought I would talk about this paper. This paper will appear in the American Mathematical Monthly sometime this year. The importance of being prime, a non-trivial generalization for non-unique factorization. Now, I will talk about briefly what's in that paper because, as I told you, it's expository. There's nothing new, but it's packaged very nicely. This paper was Nick's idea. He grabbed me by the back of the neck and said, Scott, let's write this paper. I want to write this paper. I know you share my feelings about how important these things are. Let's write this paper. Let's get it in the monthly. And about 6 months before his death, we started writing this paper. And he had to apply for tenure at Franklin and Marshall. I think his application was due in October of 2021. And I'd get all these emails from him. He'd give me deadlines. We have to have this paper done by October 1st. And we did get it done and submitted. I'm almost 100% certain it's the last paper that he wrote. I can't be guaranteed of that, although I'm pretty sure. And okay, so we got it done, we got it turned in, and unfortunately, in early November, I got a really alarming email from him. He found out about his condition, and as I said, just a month later, he was gone. So, I didn't hear anything about this paper until well after Nick had passed away about its, about its standing at the monthly. But okay, so Nick shared my philosophy that even though this is not the most important paper you're going to see talked about at this conference, it is important because it's aimed at getting people interested in what we do. And I felt early in my career that was something we were really bad at. And I think we've gotten much better at it. Writing papers like this should not be the focus of your career. But I think you should do it every once in a while. And there are some really great outlets for papers like this. The monthly, I'm a little jilted, slanted is maybe the best one, but there are certainly other ones. And in fact, what does the title of this paper really mean? Well, I would claim that maybe this was Nick's favorite theorem, because he and I talked about this a lot. It's the theorem that you've maybe seen at this meeting. But if Nick lived to write an abstract algebra book, this would be a big theorem, probably in the chapter after UFDs. An atomic monoid M is factorial if and only if every irreducible element of M is prime. The importance of being prime. If everything's prime, you got a UFD. So as many of us in this room have spent our careers thinking about it, what happens if everything isn't prime? And a lot of us have thought a lot about that question. Now, I want to take a one-slide digression to something that many of you in this room have had to listen to me talk about for a lot of years. But since this is there's a lot of young people in the audience, you're going to have to listen to it too now. And that is, as I just said, I think it's important that every once in a while we write a paper like this, because I want to show you some expository papers that people in this room have written. And I used Google Scholar for citations. I want you to look at the number of citations some of these papers have gotten. Look at this paper by Gao and Geroldinger in Expo Math. 322 citations. Go look up the best paper you think you've ever written and look at the number of citations it has. Then here's another paper from Alfred in the Monthly. I know, where are you? I know you wrote it because I beat you over the head to write it. 87 citations. That might look like a lot less than 322, but like I said, go look at how many times your papers have been cited. That's a lot. A paper by Halter Koch, again in Expo Math, 64 citations. And I put this paper up there because this was not Nick's first foray into the Monthly. He and Roger wrote a paper on factorization theory and decomposition of modules. I was the editor of the Monthly at the time, and some of my editors told me that paper was too complex to publish in the Monthly. And I told them they were wrong. I was right. It's been cited 54 times. Okay. And I know Jean-Luc, I did the same thing to Jean-Luc and Paul Jean that I did to Alfred, and they wrote a paper in the Monthly about integer valued polynomials. That one's highly cited. So I think it's really worthwhile to do this. And Nick did too, by the way. So I do real quickly want to run through what's in this paper, even though it's expository. But, you know, as I said, this was Nick's idea, and the setup for the paper was his idea. He wrote, it's like a play. It's in 3 acts with an epilogue. The main definitions and ideas are introduced through really basic, but some of the examples get to be non-basic, submonoids of either the additive non-negative integers or the multiplicative natural numbers. So they're things that students can really put their hands on and operate with. In Act 1, he starts with the integers and describes what he called their interesting children, congruence monoids, numerical semigroups, whatnot. And again, the ending moral is what I cited as his favorite theorem a second ago. In Act 2, we get into the non-unique factorization invariants and study elasticity, semi-length functions, accepted elasticity, full elasticity. It's kept at kind of a basic level. Again, you're trying to show students why this is interesting and get them interested in this. The third act does get into the omega function, which measures how far an element is from being prime, a natural thing to bring up in this paper. And the paper closes with a section on primeness in the non-commutative setting. Nick wrote this section, for those of you that know me and well know that. Okay, and I'll tell you, when I finally did get referees' reports back on this paper, one of the referees wanted me to cut this section. And I went to the editor of the Monthly and said, I don't want to cut it. Nick wouldn't have wanted it cut it. Excuse me, would not have wanted it cut. I don't want it cut. I convinced her to not cut it. So it's there. So for those of you that like the non-commutative stuff, there's a little bit at the end of this paper. Now, what I want to do real quickly is review Nick's publication record. Not every paper. So if someone in here wrote a paper with him that I'm not going to talk about, I apologize. I kind of tried to condense this into 3 groups of papers, which I think describe his mathematical development really well. These first few papers, and look, they're in really, really high quality journals. Communications and Algebra. Journal of Pure and Applied Algebra and Communications and Algebra. These are papers that appeared to emanate from his dissertation work or involved his dissertation work in module theory. So that takes him through the first few years of his time at Central Missouri State. And again, for those of you that don't know that much about the American system, the teaching load there is very heavy. So finding time to do research is difficult, okay? Now, this group of papers is where Nick's work starts to veer towards factorization theory. And the one thing I'd like to point out about all these papers is if you look at where they appear, I'll start at the bottom, involve. And there's another involve at the top. Involve is a journal that publishes papers that you write with your students. So these were all papers he wrote with Central Missouri State students. So his work is shifting towards things that he thought he could introduce the students to that have some substance to them, okay? And notice that goes up to about 2013. So what happened in 2013? He came here for a semester. And I really think that changed his mathematical life. This is a group of papers that he wrote with basically people that he started to collaborate with here. You know, Alfred, Grinkevich, Schmertig. And look, these are super high quality papers. Pacific Journal, Journal of Algebra, Acta Arithmetica. I really think that, and I'll try to emphasize this later, that Nick's work improved once he got to Central Missouri State. Like I said, I'll address that again in a few minutes. Now, I want to talk for just a minute, because I know I'm almost out of time, about 2 papers that he wrote late in his career. The first is multiplicative factorization in numerical semigroups. He wrote this with a student. It's in the International Journal of Algebra and Computation. In complement finite ideals, it's going to be in the proceedings of the 2021 meeting here in Graz. Now, there's a particular reason I want to look at these 2 papers. I'm not going to go into great detail with either one, but I want to kind of describe what's in these 2 papers. In the first one, he asked, I think, a great natural question, which oftentimes I've kicked myself for not asking myself. But take a numerical semigroup under addition, okay? It's closed under multiplication. So if you throw 1 into it, throw 0 out, and throw 1 into it. So if S is your numerical monoid, let's call S1 S, throw 0 out, and glue 1 into it. It's a multiplicative monoid, okay? It's well known that the elasticity of a numerical semigroup is very simple. It's the quotient of the largest generator over the smallest. So he called me up one day. He said, do you have any idea what the elasticity of the multiplicative monoid would be? And I said no, and I said no for a good reason, because it's not a simple thing to compute, okay? Let me talk about what's in this paper for a second. He takes this monoid called S1. In Theorem 2.1, he characterizes the atoms, and you have to do this in terms of the primes that don't appear in S, the positive primes. And there's finitely many of those. Let's call them Q1 to QT. In Theorem 3.3, he constructs the length sets for some of the things, but not all of the things in S. In Theorem 3.5, he argues that the elasticity of S1 is finite and accepted, and he gives some rough bounds on it, and they're rough. This is a complicated computation. which in this paper, he just scratches the surface of. There could be a lot more done here. And he closes the paper with 3 questions, and they're all complicated. I was going to put them up, but each one would almost take a whole slide. So, but I urge you to look at them because there's some good questions. Very few values of rho of S1 are known. And a trick that those of us that work with numerical semigroups is, well, look at a particular type of numerical semigroup and try to get something to work. That doesn't even seem to work here. If you look at this nice numerical semigroup n plus 1 up to 2n minus 1, the calculations of the multiplicative elasticity of those things is really difficult. So there could be a lot more done here. Now, as for, it's got stuck. Use the keyboard. Thank you. No, the keyboard got stuck.
Maybe space.
Oh, yeah. Does that work now? Ah, thank you. Okay. So let's go to the second paper, which might draw some of your attention a little bit more because it's a little more general. Take a free abelian monoid on a basis P, where P is the set of primes. Let S be a submonoid satisfying the following 2 properties. Its complement in F is finite, and F little s is in big S for all little f in the free monoid and all little s in S take away 1. Then S take away 1 is a complement finite ideal of F. And I talked to somebody about this yesterday. As you read this paper, he almost apologizes for using that terminology because it's really not an ideal. Okay. Again, since S is assumed to contain the identity 1, it's not an ideal, but he thought it was convenient. If you have something that satisfies CF1 and CF2, we're going to call it a complement finite ideal. So it's a monoid that you can study. There are some really nice examples of these things. Obviously, numerical monoid, generalized numerical monoids, which are affine submonoids with finite complement. And this one that I really liked, for those of us that love block monoids, it's a step beyond block monoids. It's not the monoid of zero-sum sequences, but it's the monoid of sequences that are not zero-sum free. So in this sequence, there is a 0 sequence. And it's a different monoid than the traditional block monoid. And there you can see a relationship that contains the regular block monoid and it satisfies the conditions on the previous slide. So that's a complement finite ideal. And again, in this paper, in section 5, he examines properties of this extended block monoid. There's a lot of open questions there. But again, what does he show in the second paper? The complement finite ideals are never crawl, but they are C monoids. He characterizes the irreducible elements in a complement finite ideal. And he begins to examine the arithmetic of one of these things. It's very complicated and he doesn't get too far. He gets a little bit of the way into it. So there's a lot here to think about. And that's where I want to close. Because I do want to emphasize this, because not only do I admire Nick for the courage he showed at a really difficult time in his professional life to change institutions, but he's a counterexample to an adage that many of us have heard at one time, is that mathematicians do their best work really, really early in their careers. I think he was just starting to do his best work when we lost him. And while he's gone, I emphasize these last 2 papers because there's a lot of open questions in those papers. In my idea, the best way to keep his mathematical legacy alive is to work on those problems. So thank you for letting me share with you these memories of Nick And I appreciate your attention. Now, can I have 30 seconds?
30 seconds.
Yeah, this is my commercial now that I'm done speaking. So communications and algebra, we're going into our 50th year next year. There were 6 editors here, but Pace Nielsen had to leave this morning. There are 5 editors here besides myself that can handle papers: Jim Kuykendall, Pedro Garcia Sanchez, Alfred Geraldinger, Felix Gotti, Alberto Facchini. Please feel free. This has been such a thrilling meeting, and I've seen so many great talks. We would love to evaluate your work. So please, as you put your papers together, keep communications and algebra in mind, and I'm done. Thank you.
From now, we're going to organize another conference in this series. Most of you know we've been taking turns. Alfred and his team here, and myself and some other enterprises at the other place, organizing a conference every 2 years, so every 4 years in one place. And I'm just going to write the most probable date on the board. So Wednesday, 25, most likely July. And we're going to call it I think rings and polynomial rings and polynomial conference and even though we range of topics, in fact, every topic that has been addressed in this conference. Okay, so one more challenge. I'm sure that all the class that I want to speak on this. Thank you so much.